Well, good afternoon, ladies and gentlemen. I understand we are competing with strong competitors, coffee, the view, the natural wear after a full day of works. So I'll do my best to entertain you in this last half-hour meeting. I'm going to talk about greening, so I prepared all my overheads in green. But not all greening. What I call knowledge-based greening is the new type of greening based on science, research, engineering, technology. The question to which we have to answer is it a utopia or a true revolution? I will present the facts and let you decide by the end of my talk. Start with the definition. Wikipedia, our favorite source of definitions. Green economy, according to this wise site, is an economy including improved well-being, social equity, reducing environmental risks and burdens, and all types of ecological effects, negative effects. Greening, as a verb, as an action, is the process of transformation of anything into a more environmentally friendly version. And all this is strongly supported by United Nations Environmental Programme Green Economy Initiative, which dates now for several years. So greening is a serious presence, and we have to analyze it very carefully. That's the purpose of my talk. This cartoon comes from a Dutch source, the Energy Center of Netherlands, ECN. It was part of a study about the future of technology, and the Dutch cartoonist presented this nice view of the green future. We don't have the time to analyze this green image, but my question, is it a utopia? How far can we go with this on the way to the future? Utopia sounds Greek. It is not Greek. It was made by an English scholar, Sir Thomas More, 500 years ago, exactly, when his book was published, book describing an imaginary island that does not exist. And Thomas More composed this Greek-sounding word from you, the negative, and topos, location. So utopia, since that time, is a symbol of things that do not exist, although we might wish them to. So the question between these two graphs is, where are we now? Teaching our students at the National Technical University, we developed this alphabet of greening. 24 in Greek, 26 in English letters that go through the whole spectrum of greening actions, because part of this greening mystery is the broad spectrum of greening. And we try to categorize in 26 categories the story of greening. We don't have the time to go step by step. What I did before my talk, check how many of these 26 can be applied to ships and ports. And I counted more than 20. So we are in good shape, and most of these can be useful in this conference, in the topic. Let's give an example. Number 2 is the substitution of fossil carbon by other forms of carbon. And let's take EFGH. It's about energy, saving energy, renewable energy, soft energy, energy economy. And the second part of my graph, let's start from the bottom, greenhouse effect and climatic change, health and quality of life, social acceptance, participation of stakeholders, decentralization of activities. Somewhere is the scale of actions. Small scale is closer to environmental requirements. It's not a panacea, but as part of the alphabet, scale and capacity are a major factor, because the environment cannot absorb the effects of large scale. And now some history. How old is greening? Forget about the name, the fact, the action. I believe we are close to the 40 years of greening per se, starting with the famous Club of Rome report in the late 60s and the early 70s, where the computers of MIT at the time detected some bad signs about the future. Most resources, according to that study, were about to deplete in 20 or 30 years. It did not happen. We will gain some time, but the publication of this report by Meadows, husband and wife, limits to growth. For me, it's the beginning of the history of green. It's a big warning bell. We have to do something. Our planet cannot support us. And then a list of activities. Schumacher's famous book, Small is Beautiful. The major oil crisis in the 70s, 73, 79, that were a shock to the industry. And renewables started from that. Alvin Toffler theorized that this is a revolution, actually. After the agricultural revolution and the industrial revolution, we are living through a new type of big change. That's the title of my question, revolution or utopia. The Brooklyn Report in the mid-80s defined sustainable development for the first time. The definition looks now naive, but it was a historical movement. And then United Nations activity on climate change, the Rio Earth Summits, Kyoto protocols, and I believe now greening has achieved a place in our vocabulary and in our thinking. More than a dozen approaches to greening I counted in my history as a professor and after my graduation. Different names asking about the same thing. Appropriate technology or alternative technology that was developed in Latin America is a development friendly to people and friendly to the environment. Organic system, like agriculture and food. Grassroots means local initiatives, sustainable development of course, water and waste management, smart solutions, clean technologies. This is the story of greening, and you can feel part of the problem. The negative attitude is how to homogenize this heterogeneous field. On the other hand, the issues are very important. I made a list of the reasons why we need greening, and green is the heart of the matter. Through greening, we can control the environment, help with the climate change, substitute imported or missing products, develop socioeconomic development activities, improve the quality and the security. So it's a present, it's a gift. We have to think before we decide what to do with it. This is a tool we developed in my research group trying to understand the complexity of greening. There are two dimensions, that's part of the complexity. Dimension A are the sectors of the economy. For example, ship or port are listed as A. B are the tools for greening. For example, waste treatment is a tool B. If you apply waste treatment to the ship's effluents, you have if B4 is waste treatment and A3 is a port activity, then this B4 A3 couple is not tango, is to have a form of greening. So greening can be defined through this matrix. We can put some order in the chaos of the greening definitions and greening actions. More than that, our graph can show the growth of greening. Starting from this little cell, A4, B3, we have 4 scenarios for growth. The best scenario is fertile valleys. First of all, the 2 parameters that affect greening beforehand are the science and technology excellence, that's my perpendicular axis, and the social acceptance and social partnership, that's my x. So where both are positive, you have growth. You have a spreading of greening in sectors and fields. When there is negative effect of both, you have what I call islands of survival. A piece of greening here, a piece of greening there. The 2 intermediate scenarios are intermediate growth, when one factor is positive and the other factor is not so positive. Now, let's see what are the conditions for greening. What is the revolutionary aspect when we decide we do greening? The policy. Let's start with the policy. Look at the list of policies that are involved in greening. Maritime is near to the top, but it's not alone. All these policies, and most of them are represented in the political life by ministers, have to agree on even a small action. And any one of them can veto the action if they are annoyed by it. So it's a very complex terrain, it's a mine, it's full of mines, and we have to navigate, in a good ship metaphor, and we have to find a way through. There are many strategies how we do that. We learn from looking at past successes. The past success can teach us what they did right to survive. For example, solar collectors for hot water in Greece. It's a major success. How did it happen? Second, technology. Technologies help. Look at my list of technologies. I pick technologies, technological development independent of greening that can help with greening. Start with informatics. Thanks to these tools, we can model and manage very complex systems, which was not possible before. Let's go to the bottom. Through cognitive research, we try to understand how the human mind works, why this attitude is friendly to greening and the other attitude is friendly to wasting. So energy is there, and in our workshop number 4 on Sunday, we are going to study in more detail the effect of energy, of technology, and especially energy technologies on greening. It's one of the keys of technologies, but it's only one of the dimensions. Research. Research has to change in the time of greening. Unfortunately, our old style of research is obsolete. What the new researchers should do? Let's start from the bottom. Accompany the research action by information, communication, dissemination, and crisis management. So our young researcher should be sensitive to all these things in addition to the excellence of research. So the new style of researchers should be prepared to enter the research field by all the researchers like us or universities, which means skills. Skills and dexterities are also enriched in the period of greening. Let's look at number 4. In order to describe a greening system, you need not one flow, but at least 5 different flow phenomena. Molecular, chemicals, energy, materials, information, flow through computers, financial, money, funding, and humans. Humans moving from place to place with know-how. So all experts in one of those, I'm a chemical engineer, so my specialty is molecules and materials. I must have a minimum understanding of the other flows. Otherwise, my decision will not be informed and wise. And this is a new item. And sometimes I got the question, we are lawyers and we are interested in environmental law. Do we need to study chemistry, physics, and all these things? The answer is yes and no, in a new style, yes. We need courses to inform the people, but they said we studied law to avoid science. This is the penalty we have to pay for doing greening in a more entertaining form. Next, society. This is a very important agent. Stakeholders. Again, fragmentation. Think of how many stakeholders you need to get approval in any greening phenomenon. And each stakeholder has their own agendas, and sometimes hidden agendas. What helps is visions. Visions are a glue that can put together different stakeholders. If we believe in the future of Greece, sustainable economy, this can mobilize us and for some time forget our differences. Regulation is also very helpful because it keeps us together by force. So a good combination of vision, imagination, and regulation seems to be a good recipe. But stakeholders have to be involved from the start according to a multi-criteria attitude. We have developed tools in the group, and actually the workshop on Sunday we are going to apply one of the tools with the participants, how we reach a decision. In this example, you have a number of criteria: the return of capital on investment, annual profit, national economy, regional economy, etc. And 5 or 6 stakeholders. We ask them to rank these criteria according to their own priorities. So, stakeholder A ranked the criteria number 2 as first, that was annual revenues, and then number 2, it was in his rank, it was criteria number 4, etc. This we call the decision vector. It is more or less like the Eurovision Song Contest voting, where they take a rank of songs. What do? We develop the summation of the ranks, and you can see that criterion number 2 gets the lowest score, 21, so it is the best criterion of this agreement. The stakeholders objectively agree that for this application of greening, capital cost is very important. That means involving banks, new forms of financing, etc., etc. Comparing the vectors, let's say, of partner A, of stakeholder A and stakeholder C, the smaller is the number, the closest these two partners are. And you can see this number 12 is the smallest of all the pairs. So this pair of partners, A and C, if I remember well, it is technology and environment, sitting next to each other. They look at the graph and say, we are allies, because our opinion vote is very close. So we can use that to reach a decision. We don't have the time to give examples. This is a very quick example. How can, according to our research on technology, how can reduce the cost and emissions by changing the fuel in the city? Use a clean fuel derived from waste, biomass, or other natural resources. And you can, based on that, we can modify the technology, reducing this, and we can redesign the system to accommodate the new element. This means, and this is my last one, that first of all, greening seems to be not exactly a revolution, but seems to be symbiotic with the quest for sustainable development. Most of the elements I presented can be part of a sustainable development strategy, for example, for Greece. The main path is product innovation. And unfortunately, this comes from a process engineer, chemical engineer. Process is secondary. The first priority of producing innovation is through products, services, and quality. That's why we propose to change the fuel in the city. Start from that. The process will come later. How can we improve the fuel production, the clean fuel production? And last but not least, system innovation is very important. So for me, green seed or green port represent important opportunities for systems innovation, but because by changing the system, we can find the niches to introduce products, qualities, services, and processes. And with this, I would like to thank you for your patience and offer my email for more questions and clarification. Thank you.
Thank you very much. Are there any questions? Please.
Okay, thank you very much. Thank you very much for your presentation. I have a question related with this exercise with the stakeholder.
Yes.
How you are avoiding the stakeholder bias? I mean, if I'm taking a stakeholder, possibly is biased to some, needs a very, very careful elicitation of the stakeholders that they are responding. So how you are assuming that you are not biased their response?
Well, this is one of the challenges, and so that's why we need research to clarify and improve the tool. We use the students as models, and we are running this as a postgraduate course part, so we have improved through the testing. The story is, for example, take any form of greening, a clean fuel for a ship. How many groups participate in this decision making? The green fuel producer, if not the resource producer, the green fuel maker, the technology, transportation, the boat conditions, the waste, economy, capital. So we avoid more than 10, let's say. We ask representatives, not one person, from the group. 2, 3, 4 persons make the group of clean fuel production. And we ask them first individually, the 4 members of the group, of the one group, to rank the priorities according to their own personal field. We collect this to see. And then we ask them to make a group meeting and homogenize their answer to one. What happens if they have their own biases? Because they are, as a group, they have differences, although they are represented the fuel producer. But we ask them to agree on one and report the agreement and the possible deviations. And we do that for all the groups. And then each group starts presenting on the board and we make all the calculations. Normally, a second vote would improve a lot the voting. But we don't have the time to do that, and whenever we did that, from the start, after I know what you have voted, my vote becomes better, not worse. I'm not scared to say the negative. I am encouraged by the other people to get out of the closet and present my views. But in one round, the results were very good. We do them from year to year, and they reflect the present conditions. For example, employment as a criterion has improved a lot in the last years because of the Greek crisis of unemployment.
So you are not using some Delphi methods, possibly between the student without knowing who is voting and what is?
Not in this case. We have done Delphi for the future of technology in Greece. It's for the experts, let's say. But it's a new field of research, and sociologists alone or other experts cannot do that. We need to work with them to develop good, clever questionnaires. So we are open to collaboration with experts like you.
Taking this great opportunity with your very nice presentation, I was just a little bit brainstorming with myself, and a question derived that is, finally, is there any bottom at the room for basic research?
Oh, that's a tragic question, because nobody seems to
I
be
was just
interested.
brainstorming because I've seen the European Commission, especially in the last years with Horizon 2020, tries to bring together innovation with the stakeholders and confuse all the things, because exactly as you mentioned it, it's more business orientated on future actions, and this is our future. So I'm asking myself a lot of times.
Well, I tell you the story of an old friend of mine who is now in the other world, Professor Nikos Margaris, famous for his Vima articles every Sunday, a good ecologist and scientific ecologist. When the Greek government abolished basic research in the mid-80s, he wrote a piece on the wife of the minister. She goes to take a swim, and there are some medusa plant animals that make a problem on her skin, and that's because we stopped research on marine biology. The revenge is there. So maybe the definition basic is not correct. Fundamental information oriented to application is the best term. But fundamental knowledge, we need fundamental knowledge. Most of my, think of chemistry. Chemistry is changing to green chemistry, molecular, smart chemistry. This is basic research, basic or fundamental research. And we can kill the future of research with a bad decision.
Exactly, because as far as I know, especially in the field of nanotechnology, there are very huge debates. Some find solutions and some find problems. So I was just wondering. Thank you.
Okay, research is here to study both of them.
Any more questions?
I would like to add just a comment. Part of our research is how to teach these things. You understood from a couple of my examples. And we're glad to collaborate with Mr. Koukios systematically on research on cognitive sides or cognitive aspects of learning. Learning is a very important parameter. And we should not leave learning only to brain scientists. We need to use in class and ask, our students are different. They don't focus too much. They are more visual than sound-based. But we have to know the audience, and we do a lot of research, and when we publish, we have presented the research, the results are very positive. In a past conference, one of the American experts sitting in the front told me, I would like to be in your class. I would like to be a student. This is the highest praise of a teacher. So research, but in a different style of research. When in Switzerland there was a referendum on the future of genetic research, scientists came out of the labs wearing their white coats and convinced the people that they should vote yes, because research should have a future. And the Swiss people, despite their conservative attitude, voted in favor of genetic research. But are we prepared to get out on the streets with our coats or? I don't know.
We are not Switzerland.
Yes. Yes.
Thank you very much.